Hello, good evening all. Still joining. Today somewhat late. Okay. Madhurima, Mamata, Swati, Josna, Sandeep Neta, Kamala, Jitendra, Gopasri, Sudha, Sunita. Okay. Right. Preeti. Okay. Right. Vijayvardhan, Ashish. Right. So in the last class actually we have discussed. Thank you Chandana. Sneha. Okay. Vardhan. Right. Bilvika. Okay. Talluru. Possibility. Okay. So in the last class actually we have discussed different formulae on limits. So today we will concentrate on the problems. So after this chapter try to start vectors. Okay, I will try. Okay. So once again good evening all. Okay. Ramasubha Reddy. Okay. Satyanarayana Murthy. Adabala. Okay. Mallaya. Chintu. Okay. Vijayvardhan. Okay. Today some new viewers are there. Subscribe, like and share. Okay. Danusha, how are you? Okay. Oh. Harinarayana. Okay. Venkatram. Okay. Upendram. Hare Krishna. Ashish. Okay, let us start now today class. So if you want the formulae, once again you go through the previous video. So that is recorded version is available in our site. Okay. Right. Okay. Is it audible? My voice? Okay, everybody. Okay, thank you. So now limits. So yesterday only we have started this chapter. Okay. So now the first question. Let us start with the first question. Limit x tends to 0, kth root of 1 plus x minus 1 upon x equals here k greater than 0, k is positive, equals to first option k, second option minus k, third option is 1 by k, fourth option is minus 1 by k. So this is the question. Okay, you are too fast. Good. Okay, right. Madhurima 1 by k. So now limit x tends to 0, kth root of 1 plus x minus 1 by x. So that means first of all solution, let us write like this. limit x tends to 0, this kth root of we can write 1 plus x whole to the power of 1 by k and minus 1 by x. Okay. So, now yesterday we have studied one formula, limit x tends to 0, this 1 plus x whole to the power of n minus 1 by x equal to n. So, you remember this formula. So, with the help of this formula, here answer we can write 1 by k. Yes, absolutely correct. 1 by k is the right option, third option. Now, the second question. Limit x tends to 1, 2x minus 3 multiplied by root x minus 1 upon 2x square plus x minus 3. This is the question. Okay. Screen is not clear. Okay, it may be actually your problem there. Now, screen is clear or not? No? Wait, you will be getting. Net problem is there. Okay. Now, first option is 1 by 10. Second option is minus 1 by 10. Third option is 2 by 5. Fourth option is minus 2 by 5. This is the question. Thank you. Clear? Okay. Now, it is clear. Okay. So, now the today new viewers are there, actually you need to subscribe. Okay, Bharat. Yes. So, now limit here x tends to 1. Okay, 2x minus 3 into root x minus 1 by 2x square plus x minus 3. So, if you substitute the limit, what happens means, here definitely here root 1 is 1 minus 1 0, 0 into something 0, here 2 plus 1 3 minus 3 0 by 0 form. So, that is why first let us find out the factors of 2x square plus x minus 3. Compulsory as x approaches to 1 means x minus 1 will be the one factor. So, that is why other factor we need to find out like this. 2x square plus x minus 3 means you apply synthetic division method. 2, 1, minus 3 write down. Put x is equal to 1 here. Starting 0, here you get 2. Now, 2 into 1 plus 2, you get plus 3 into 1 minus 3, 0. So, that means now this can be written like this. Limit x tends to 1, 2x minus 3 into root x minus 1 upon this will be, you can write 2x plus 3 into x minus 1. Here actually we have one formula, limit x tends to 1, x to the power of n minus 1 by x minus 1 is n. So, the limit can be applied to the two functions, limit x tends to 1, 2x minus 3 by 2x plus 3 into limit x tends to 1, x to the power of minus 1 by x minus 1. Okay. Now here substitute the limit 2 minus 3 by 2 plus 3 into, using this formula, this can be written 1 by 2. So, this is equal to minus 1 by 5 multiplied by 1 by 2. So, we get minus 1 by 10. So, second option is the right option. Yes, yes. So, we need your encouragement. Yes, synthetic division is better one. Instead of factorizing, it takes a lot of time. It will be so easy. Okay, right. So, now third question, limit x tends to 0, cube root of 1 plus sin x minus cube root of 1 minus sin x upon x equals to. So, first one is 0, second one is 1, third one is 2 by 3, fourth one is 3 by 2. Okay. Not clear, sir, again. Okay, it will be getting. Now, it is clear. Oh, answer is 2 by 3. Wonderful, 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 wonderful. Okay, right. Here see, the limit x tends to 0, cube root of 1 plus sin x minus cube root of 1 minus sin x by 3. See, yesterday we have studied one concept. So, what is the concept means? As x is very small, x approaches to 0, the sin x is approximately equal to x. Now, this problem can be changed as like this: limit x approaches to 0, 1 plus x whole to the power of 1 by 3 minus 1 minus x whole to the power of 1 by 3 upon x. So, this equal to 1 by 3 and minus of minus 1 by 3. So, this equal to 1 by 3 plus 1 by 3, whose value equal to 2 by 3. So, that means third option is the right option. Absolutely correct. Okay. Okay. Hare Krishna. Right. Gopasri. Samir. Yes. SK Samir. Dhanusha. LHS rule is also best, but actually it takes a lot of time. Lengthy. Sir, in the previous sum 3 minus 3 is equal to 0 is wrong. Where? Previous sum. Where? 3 minus 3 is 0. Where 3 minus 3 0? No. Okay. Here. Wait. That I will write it. So, good observation. This is plus 3 only. 3 into 1 plus 3 minus 3 plus 3 0. Okay. Synthetic division. Okay. Right. But we got it now. Now, fourth one. If limit x tends to 5, x to the power of k minus 5 to the power of k upon x minus 5 equal to 500, k greater than 0, k is positive, then k equals to, what is the value of k? Okay. So, now first option is 3, second option is 4, third option is 5, fourth option is 6. This is the question. Okay. Thank you, Sandeep. Right. So, now limit extends to phi x to the power of k minus phi to the power of k by x minus phi equals to 500. When k greater than 0, you need to find out the value of k. So, that means actually here, so first let us write this limit extends to phi x to the power of k minus phi to the power of k by x minus phi equals to 500. See, we have the formula limit extends to a x to the power of n minus a to the power of n by x minus a, that is n into a power n minus 1. This is the basic first fundamental formula. So, this can be written k into phi to the power of k minus 1 equal to 500. So, just better verify the options now. First option. So, first option, let us take k is equal to 3. So, that means actually here 3 into phi square, that is equal to 75. 75 does not equal to 500. So, first option here has been ignored. So, now second option k is equal to 4. So, now 4 into phi cube, that is 4 into 125, that is 500. Yes. So, that means second option is the right option. Second option is the right option. Right. Thank you. So, now increase the font. So, now fifth question. Limit extends to 1 root of x square minus 1 plus root of x minus 1 upon root of x square plus 1 equals to. So, now the first one is 1 plus 1 by root 2, second option 1 minus 1 by root 2, third option is minus 1 plus 1 by root 2, fourth option is minus 1 by root 2. This is the question. So, now, so let me read the question once again. Limit extends to 1 root of x square minus 1 plus root of x minus 1, this is x minus 1, x minus 1, okay, upon root of x square minus 1 equals to, if you put x is equal to 1, this is 0, 0, 0 by 0 form. Even if you apply L'Hospital's rule, you will get the answer. Otherwise, so root of x square minus 1 by root of x square minus 1, these two gets cancelled, and this x square minus 1 can be factorized, that is x plus 1 into x minus 1, root x minus 1 cancel, just substitute the limit. So that is also easy method we have. So let us follow like this. So limit x approaches to 1, this we can write root of x square minus 1 upon root of x square minus 1 plus root of x minus 1 upon root of x square minus 1. Okay. This gets cancelled. We have limit extends to 1 or x approaches to 1. We have 1 plus, this is root of x minus 1. This can be written as root of x minus 1 into root of x plus 1. You please check it. So this gets cancelled. Now substitute the respective limit now. 1 plus 1 by root of 1 plus 1. So this equals to 1 plus 1 by root 2. So that means first option is the right option. Check it now once again. Okay. Right now. Okay. So now the sixth, a greater than 0 and limit extends to a power x minus x power a upon x power x minus a power a equals to finite value minus 1. Then a equals to, okay. First option is 0, second option is 1, third option is E, fourth option is 2E. This is the question. So that means actually in order to solve this problem, so we need to do, actually we need to remember, we need to recall even the derivative of a power x and derivative of x power n and derivative of x to the power of x. Okay. So now that means actually if you substitute limit x for a, you get a power a minus a power a 0, a power a minus a power a 0. So you try here. So if you substitute the limit, you get like this, a to the power of a minus a to the power of a upon a to the power of a minus a to the power of a, which is in the form of 0 by 0, that is indeterminate form. So that's why, so now the solution, apply LH rule, apply L'Hospital's rule. Here limit extends to a power x derivative is a power x log a, that is base e only, x power a is a into x to the power of a minus 1, and upon x to the power of x derivative is x to the power of x into 1 plus log x, and minus a to the power of a is constant 0. equals to minus 1. Now substitute the limit, you get like this: a to the power of a log a minus a into a power a minus 1 by, okay, this will be a to the power of a into 1 plus log a, okay. Now what do you get now here? This equal to minus 1. Now here you see a to the power of a log a minus a into a power a minus 1. A into a power a minus 1 is a power a by a power a into 1 plus log a equals to minus 1. And next we have a power a common, we have log a minus 1 by a power a into 1 plus log a equals to minus 1. Now a power a gets cancelled. If you cross multiply, you get log a minus 1 is equal to minus 1 minus log a. So you get now 2 log a is equal to minus 1 plus 1 0, that means log a equals to 0. Therefore, this is equal to log 1, a equals to 1. This is the answer. So, second option is the right option. Okay. So, here see, differentiation of a power x is a power x log a. Differentiation of x to the power of a is a into x to the power of a minus 1. Differentiation of x to the power of x is in derivatives we have done x to the power of x into 1 plus log x. Derivative of a power a is constant 0 and which is equal to minus 1. Now put in the place of x a to the power of a log a minus a into a to the power of a minus 1 by a to the power of a into 1 plus log a equals to minus 1. See the next step, a to the power of a into log a into a to the power of a minus 1 plus 1. So, a to the power of a by a to the power of a into 1 plus log a to the power of a is taken common out. So, we have now log a minus 1 by 1 plus log a is equal to minus 1, cross multiplication we get log a is equal to 0, 0 means log 1, so a is equal to 1. Okay. Thank you Danisha. So, you are using fast track Eamcet, okay, you have it, thank you, thank you, thank you, thank you. So, generally I do not have any idea, so it might be there in that books also, may be available. Okay. Seventh question, limit x tends to 0, x into 1 minus root of 1 minus x square, okay, upon root of 1 minus x square of sin inverse x cube equals to first option 1, second option 1 by 2, third option is minus 1 by 2. So, fourth option is minus 1. This is the question. So, Ashish, leave it that book now. Okay. This is not the book you can see. Is it visible? Okay. Right, thank you. Leave it. So now, so let us make a plan here. Limit x tends to 0, x into 1 minus root of 1 minus x square by root of 1 minus x square into sine inverse of x cube. Okay. Here let us do one thing, right. Here 1 minus x square we have, okay, 1 minus root of 1 minus x square. So now this sine inverse x cube also you can write as x approaches to 0, you can write x cube when x is tends to very smaller value. Now the problem becomes like this: limit x tends to 0, x into 1 minus root of 1 minus x square upon root of 1 minus x square into, you can write x cube. So now this is x 1 ja x square, you can write it. So now put x is equal to sine sine theta. As x approaches to 0, theta also approaches to 0. X approaches to 0, sine theta is equal to 0 means theta also approaches to 0. So this we can write like this now: limit theta tends to 0. See, now here 1 minus root of 1 minus sine square theta upon root of 1 minus sine square theta into here x square. X square means we have sine square theta. This is limit theta tends to 0. This will be root of 1 minus sine square theta is cos square theta, cos theta. This is cos theta into sine square theta. As theta is very small, sine square theta is we can write theta square. So now we can write limit theta tends to 0, 1 minus cos theta by theta square into limit theta tends to 0, cos theta is equal to 1 by 1. 1 minus cos theta by theta square is 1 by 2. So 1 by 2 into 1 by 2. So this is the second option is the right option. Okay. So now eighth question. Krishna, you might have joined just now itself only, I think. Okay. Yes. So eighth question: if limit x tends to 0, cos 4x plus a cos 2x plus b upon x to the power of 4 is finite, is finite value, then the values of a comma b respectively, okay. First one is 5, second option is minus 5 comma minus 4, third option is minus 4 comma 3, fourth option is 4 comma 5. This is the question. Seventh one I will explain later, don't worry. So, the most of the once again say about seventh question. Okay, okay, I will repeat. Okay, okay, last steps I will explain, don't worry. After completion of this question I will switch over to the once again seventh question. Now is it visible to you, all of you? Am I audible? Visible? Just type it. Okay. So, now limit x tends to 0, cos 4x plus a cos 2x plus b by x to the power of 4 is finite. Then the values of a and b we need to find out. Here it is finite value means if we put x is equal to 0, so it must be in the form of 0 by 0 form. That means if you substitute in the numerator x for 0, numerator should be equal to 0. That means as x approaches to 0, the numerator should become 0. So, therefore, we get cos 0 plus a cos 0 plus b should be 0. Cos 0 is 1 plus a plus b equals to 0. So, we get now a plus b equals to minus 1. Now, you need to verify the options. So, first is actually ignored, second is minus 5 minus 4 minus 9 ignored, C second option minus 4 plus 3 equals to minus 1. Yes, third option is the right option. A, B, yes, but option 1 had only one value, that is why we can ignore it. Huh? So, now let us move to the ninth question. Am I correct now? Ninth question? Ninth question. Sir, you wrote 2 pi by 3. Where 2 pi by 3? Where 2 pi is 3? Chandana, sir, seventh one. Okay, okay, okay. I will repeat, don't worry. Limit x tends to 1, secant pi x by 2 into log x. Equals to first option minus 2 by pi, second option is minus pi by 2, third option is 2 by pi, fourth option is pi by 2. Okay. Limit x tends to 1, secant of pi by 2 into x into log x. So, if you substitute the limit, what will happen? Let us see. If you substitute the limit sec pi by 2 into log 1. So, sec pi by 2 is not defined, this will be infinity into 0, it is indeterminate form. If it is in the form of infinity into 0, we cannot use L'Hospital's rule. In order to apply the L'Hospital's rule, so it should be 0 by 0 form or infinity by infinity form, then we can apply. So, that means now this we need to change now. So, this can be changed. Write the reciprocal of secant of pi by 2 x. Secant theta equals to 1 by cos theta. Okay, definitely I will update today. Okay, limit x tends to 1, this can be written as log x upon secant pi by 2 x. Now, this will be in the form of infinity by infinity, so that we can apply LH rule. LH rule. LH rule. So, if you apply the LH rule, derivative of log x is 1 by x, numerator derivative, secant pi by 2 x derivative is secant, sorry, this is cos, forgotten, wait for a while, I did mistake. Okay, this is cos of, sorry, cos of derivative is actually we have minus sin pi by 2 x into pi by 2 x derivative is pi by 2, but limit is applied how much? Limit x tends to 1 itself only. So, now let us substitute the limit. Now we have here 1 by 1 upon, we get minus sin pi by 2 into pi by 2 means 2 by pi. This is sin 90 is 1, 1 by 1 is 1, minus 1 into 2 by 5, minus 2 by pi is the right answer. So, first option is the right option. So, log, yes, log 1 is 0, it's absolutely correct. This is not infinity by infinity, I did not check it, it's absolutely correct. Log 1 is 0 and cos pi by 2 is 0, 0 by 0 form itself only. Thank you, thank you. But even 0 by 0 or infinity by infinity, we can apply LH rule. Okay, Sriyana, first subscribe, no problem, first subscribe. Now, the 10th question, limit x tends to 0, root of 1 plus x square minus root of 1 minus x plus x square upon 3 power x minus 1 equals to. Okay. First one is log 9, second one is 1 by log 9, third one is log 3, fourth one is 1 by log 3. This is the question. Tarun, Vicky, you are new to my class, I think so. First, have you followed all the videos, previous videos? Okay, right. Limit x tends to 0, root of 1 plus x square minus root of 1 minus x plus x square upon 3 power x minus 1. Let us substitute the limit now first. Root of 1 plus 0 minus root of 1 minus 0 plus 0 by 3 power 0, 1 minus 1. This will be 1 minus 1, 0 by 0 form, indeterminate form. You can apply L'Hospital's rule, or you can rationalize the numerator also. Any of the method you can apply. So, first, for example, if you differentiate it, what do you get now here? Solution. Apply LH rule, L'Hospital's rule. Root of 1 plus x square is 1 by 2 root of 1 plus x square into 1 plus x square differentiation is 2x. okay, minus this will be 1 by 2 root of 1 minus x plus x square, its differentiation is minus 1 plus 2x, okay, upon 3 power x differentiation is 3 power x log 3 and minus 1 differentiation 0. So, limit x approaches to 0. Now, substitute the limit. Let us see what do we get it now. The first term becomes 0 because 0 by something 0. Here minus of you will be getting, this will be 0. So, minus of minus plus 1 by, this will be 0, this will be 0, 2 by 3 power 0 is 1 log 3. So, we have 1 by 2 log 3. This we can write as log 3 square. So, 1 by log 9. So, second option is the right option. Tarun, actually you need to follow my videos and beside that you need to follow other materials also. Okay. Right. So, 11th question, limit x approaches to 0 sin x by root of x square. So, first option is 1, second option is minus 1, third option is 0, fourth option is does not exist, does not exist, does not exist. Option 1, let us see. See, the limit x approaches to 0 sin x by root of x square. Okay. Now, here we have one concept need to be addressed. The root of x square is equal to mod x. The definition of the mod x is equal to x when x greater than or equal to 0, equal to minus x when x less than 0, or even mod x is equal to, you can write maximum of minus x comma x. You can remember this one also. So, that is why now the question becomes like this. So, limit x tends to 0 sin x by mod x. So, that means here in this case we need to find out left hand limit and right hand limit, both will be you get different. So, that is why limit x tends to 0 sin x by root of x square does not exist, does not exist. So, fourth option is the right option. So, the 12th question, limit x tends to 0 e power x minus e power sin x upon 2 into x minus sin x equals to, first option minus 1 by 2, second option is 1 by 2, third option 1, fourth option 3 by 2. This is the question. Okay, sir, you will also discuss the mains question paper. Yes, the previous question papers I will discuss later. Okay, fourth one, 3 by 2. Let us see. When will you explain straight lines? Okay. So now limit x tends to 0, e power x minus e power sin x by 2 into x minus sin x. If you substitute the limit e power 0 minus e power sin 0 also e power 0, 2 into 0 minus sin 0, 0. So 1 minus 1 by 0 minus 2 into 0, 0 by 0 form, indeterminate form. So you can apply here L'Hospital's rule, or directly also we can do take e power sin x common. So directly we will get it now. Solution: e power sin x common. So you will get like this: e power x by e power sin x minus 1. Now open the brackets, you will get same thing itself only, and by we have 2 into x minus sin x. Here limit x approaches to 0. The next step we get like this now: limit x approaches to 0, e power sin x into, this we can write a to the power of m by a to the power of n, a to the power of m minus n, e to the power of x minus sin x minus 1 by 2 take common, no problem, this 2 is taken common out, constant, x minus sin x. Suppose you say this is t, this will be t, that means e power t minus 1 by t, this is 1, e power sin 0 is 1. So half into e power sin 0, e power 0 1, and e power t minus 1 by t. For example, x tends to 0, even x minus sin x also tends to 0. That means you get like this, you can change the limit. Limit t tends to 0, e power t minus 1 by t. This is standard result. So half into 1, answer is 1 by 2. So second option is the right option. Are you getting visible or not? You need to chart in the chart box. Are you getting or not? Are you getting? Chandana, what about Chandana? Raju? Now okay. I think there is a problem. How, sir? I cannot understand. See, very simple actually here. See, let us say t is equal to x minus sin x. For example, x approaches to 0. The t also approaches to 0 minus 0. That's I changed here. Limit t tends to 0, e power t minus 1 by t. That is 1, half into 1 half. Okay. So now 13th one. Limit x tends to 0, 1 minus cos cube x upon x sin 2x equals to. Now it is clear, voice is clear, okay, voice is clear or not? Okay. First option is 1 by 2, Second option is 3 by 2. Thank you, thank you, thank you. Third option is 3 by 4. Fourth option is 1 by 4. Okay. Limit extends to 0, 1 minus cos cube x by x into sin 2x equals to how much? Here actually let us make the plan like this. Our plan of action will be like this. First is a cube minus b cube formula I would like to apply, that is a minus b into a square plus ab plus b square. That means the 1 minus cos cube x can be written as a factors. Next, as x approaches to 0, the sin 2x I would like to write sin 2x approximately equal to 2x. So, these I would like to apply. And next, one more thing I would like to apply. This is second plan. Third plan is limit x approaches to 0, the 1 minus cos x by x square. Already yesterday we have discussed, that is 1 by 2. This is standard. Okay. So, now let us apply these plans now. Solution: limit x tends to 0, this 1 minus cos cube x is written as a minus b 1 minus cos x into a square 1 square 1 ab 1 into cos x plus cos x whole square cos square x upon this x into sin 2x is 2x. Now, you can separate the two limits. This 1 by 2 is common. Limit x approaches to 0, this x into x is x square 1 minus cos x by x square, okay, into limit x approaches to 0, 1 plus cos x plus cos square x. This equals to half into, so using this concept, this value will be 1 by 2, okay, into 1 plus cos 0 is 1, cos square 0 is also 1. So, this will be 3 by 4. So, third option, option 3. Am I correct? Nitin Kumar, wait, you will be getting. So, there is a problem, I think so. So, otherwise you can watch tomorrow also. Okay, there is a problem, I think. Today we will conclude, and also seventh problem also. Why should we not apply L'Hospital's rule? Why you can apply L'Hospital's rule, no problem. You can apply, you will get it. You will get it. Okay.
Clear. I think the net problem. They are using mobile data. There will be a problem for them.
Okay.
Tell them.
So, now the seventh problem. Let me discuss the seventh problem here. Okay, there might be the net problem with you.
If they are using mobile data, they will be having a
Yes. Okay. So, now here see, sin inverse x cube, I have written approximately x cube here as x approaches to 0. That means, in the place of sin x cube, here see, so this sin x cube, I have written x cube here, and x, this x and x, here you get x square. Now put x is equal to sin theta. So, as we are changing x for sin theta, even limit also we need to change. Put x is equal to 0 means here sin theta is equal to 0. That means theta is 0 approximately. So, theta is equal to tends to 0. So, now limit theta tends to 0. So, here x is replaced by sin theta, root of 1 minus sin square theta by the root of 1 minus sin square theta into sin square theta. Again, if limit theta approaches to 0, sin theta will be theta, but sin square theta is there, that I have written theta square. So, here cos theta we have. I separated both the limits. Limit theta tends to 0, 1 minus cos theta by theta square, and also this I will write limit theta tends to 0, 1 by cos theta. So, 1 by cos theta means cos 0 1. This is already discussed. 1 minus cos theta by theta square is 1 by 2 into 1 equal to 1 by 2. So, option is 2. I hope it is clear. We are not perfect in applications of L'Hospital's rule. No problem, no problem. Because actually you need to go the derivatives. If you are actually good at derivatives, we can solve even limits. That is why only I started differentiation first. So, first watch my derivatives videos, so that you will get perfection in the derivatives. After that we can solve the limit chapter. That is a better one. Thank you. Bye bye. Yes.